Hello and welcome. In this video, I'm going to show you 5 different techniques to find out why your app is crashing or behaving strangely. Now, why is this so important? It is because nobody writes code that is perfect on the first try. The process usually looks like this. You write your code, you test it out, and if it doesn't work out, you go back and you tweak it and you try it again. However, if your code works and runs perfectly on the first try, then you get to do your happy dance. But wait, you're not done, because now you have to put on your hacker hat and you have to try to break your code. You have to think about all of those small edge cases and all of the scenarios where your code might not hold up. And if you actually do manage to break your code, then you have to go back, fix it, and then test it again, and the cycle repeats and repeats until you have your code as bulletproof as possible. Like I said, this stuff doesn't happen on the first try. That's why it's so important for you to know how to debug and troubleshoot your code. Luckily, Xcode gives you a lot of tools to make this happen, and in this video, I'm going to show you what they're all about. So we're going to talk about logging first because it's your most basic form of debugging, and in many cases, it's also a preemptive measure. We're going to be demonstrating logging as well as the other debugging techniques in the Match app project, which we've been building so far in this module. And just in case, for those people who are jumping into this lesson who hasn't been following along in this module so far, let me just quickly explain how this UI gets generated with this collection view of cards. So it's very, very simple. We have a view controller which asks the card model for a bunch of randomized cards, and this function, getCards, will randomly generate an array of 16 card objects and then return that to the view controller, who will then display it in the collection view. And that's how we see all of those 16 cards in the scrollable collection view. Okay, so you already actually see some logging down here, and this is simply output which you can put into this console area using the print statement. So let me show you what that looks like. Here in the card model, in this getCards method, what we do is we loop 8 times, and for each of the 8 times we generate a random number, and I'm simply using this print statement to print out that random number to the console. Quick note, if you don't have this area down here, there's actually this button that controls this little tray, and this part also has 2 panes here, which can be controlled by these 2 icons down here. I know it's a little hard to see, but you're going to want both of them visible, and you're going to want this tray visible as well. So in terms of logging, if you were logging more information, it would probably be useful to have some sort of text describing what these numbers are. So you might say something like, generating a random number, and then you would just use variable insertion into your string like that. Let me just run it again to show you, and then you get some output like this. And at the end, after it just passes back the array, you can use another print statement just before, and you can maybe print out the count. Well, you probably put some sort of descriptive statement there, so it's not just a number, but as long as you know what it is and you're working alone, that's fine. So the reason logging is very useful is because it allows you to see if your code is generating the results that you expect. So as I'm writing through all of this code in this method, if I didn't print anything out, my assumptions would be that I would generate 16 cards, and they're going to be 8 pairs of random numbers, and I would return an array of 16 objects. That would be my assumption if I didn't print anything out. But by writing these print statements, when I run my app, I can visually see that that indeed is the case. So I've got a bunch of random numbers for the iterations, and I've got 16 card objects about to be returned to the view controller. Notice that I'm not really doing this because I think my code is broken, but I'm doing this just to verify my assumptions as I'm going along. And if something does go wrong, I can actually just go through my console log here and take a look to see if my code is generating the results that I want. Now, logging can also be a troubleshooting method. So for example, if in
the simulator, somehow I see that I'm missing a card, or I have extra cards or something like that, or maybe the cards that I do have, they're not matching up. I don't have 8 pairs of matching cards. So at that point, I might go back to this method here. If I'm suspecting that this method might be generating some weird behavior, I might put print statements everywhere, right? And I might run my code and then make sure that all of the variables are checking out, and objects are getting added to the array properly and stuff like that. Another way that you can use logging statements is in response to user interaction. So a lot of the time you might be trying to handle a user taps. For example, I'm tapping on this card, I'm expecting it to detect that and flip over. Well, where does this detection happen? What if you're tapping on this card and it's not flipping over, and you're wondering if your tap is being handled at all, and if it's being detected and handled, why isn't it flipping over? Well, in this case, you can go into the view controller and you can go into collection view did select item at, because this is the delegate method that gets triggered when a cell in the collection view is tapped. So you might put a print statement here saying that a cell is tapped, and you might even go so far as to say cell is tapped, and then maybe insert the index path.row to indicate kind of which cell is tapped. So if you run your project again and you're tapping on a cell and you see that print statement, you see down here cell is tapped, then you know at least that the tap is being detected. Now the next step is to figure out why it's not flipping over, if it wasn't flipping over, and trying to troubleshoot that. However, if let's say you're tapping on this guy and it's not flipping over, and you don't even get this print statement here, then you know that it's not even detecting your tap. So then that gives you a clue that maybe something is blocking that collection view, or maybe that collection view is not handling user interaction. So it kind of shifts your train of thought and troubleshooting to another path. Okay, so now let's take a look at our second debugging tool, and this one is really powerful, and you will probably be using this one the most often, and that is breakpoints. And the reason why I say logging is kind of preemptive is because to do this sort of troubleshooting when you detect a problem, breakpoints are actually a great way to do it, and it's faster than having all of these log statements. So when I'm coding, I will use log statements in my code to verify my assumptions and to double check and display that the values in the variables are what I expect. However, when something goes wrong, let's just use that example again where I'm tapping a cell in this collection view and it's not triggering the card flip. So in this case, I can actually just use a breakpoint to see if it's going into this method instead of putting a print statement here and then having to run the project again and relying on seeing visually this console log. So let me show you how the breakpoints work. If I wanted to see if the execution went into this method, all I would have to do is set a breakpoint right here, because when the execution hits that line of code where you've set a breakpoint, that execution will actually pause and you're going to be able to see a green line here. So let me demonstrate this. Actually, I didn't need to rerun my project. That's the nice thing about breakpoints, where you can actually set them and you can delete them without having to rerun your code, because it's not a code change. So you click it to activate a breakpoint, you click it again to deactivate it, or you can toggle it actually, and to completely remove it, you can just drag it off of the gutter. So let's see it in action here. If I tap on this guy, you can see that Xcode comes to the foreground and it highlights this line where the execution has stopped at my breakpoint. So this tells me that the execution is coming into the did select item at method. So it is handling and detecting my taps. However, if let's say that there's a button here to continue program execution, And I'll talk about those buttons in just a sec. But let me just say that if I tap this cell and it wasn't hitting this breakpoint, that means that this method isn't being fired because the execution would have stopped at this line of code if it did come into this method. Right? So you can use breakpoints to see if execution goes into certain methods or reaches certain branches in your if statement and stuff like that. The other thing that breakpoints are awesome at is if, let's use that example again we used before, where let's say you're missing a card or you have an extra card. So you suspect that maybe the card model isn't returning the number of items that it should be returning. So that's where you're going to look first. So you go into your code and then you jump to, let me just remove this breakpoint. You jump into the card model, or maybe let's just stay in the view controller here. If we scroll up to the view did load, you can see here in this statement where we call model.getCards. And this is going to basically fetch that array of card objects and assign it to this card array property that we have up here. So I might put a breakpoint right after that line so I can stop the execution as soon as that has happened, and then I can double check that that card array contains what I expect it does. Now in this case I do have to restart my project because the view did load method has already run. So I just need to restart my app so that it hits the view did load method again. So here, what you can actually do is put your cursor into the console window and you can use a command to double check what's in different properties, variables, and objects, just to verify that those things contain what you are expecting. So for example, I want to double check the number of objects in my card array. So I can actually type in PO, which stands for print object, and then you can put in the name of the object that you want to display. So in our case, we are going to type in card array, and you also get autocomplete in this console window, so that's really nice. So PO, we've got 16 elements in this array, and you can see all of the indices here. Each one has a card object. Now if I wanted to drill down into a specific element, let's say card number 15, or this would be the last card, this would be card 16 actually, I could do something like PO, and you can actually press up on your keyboard to use a command that you previously wrote, so you don't have to type as much. Now let's access element 15, and I can use dot notation, and I can actually access one of the properties, and I can just double check, for example, what card it is. In this case, the 16th card is the card image that we have in the asset library called card 11. Now one thing I want to point out is that notice that my breakpoint is after the variable getting set, because had I set the breakpoint right here and it paused on this line, let me just show you. When it pauses on this line of code here, it hasn't yet executed that line of code. So if I go here, right, it stopped up here on this line right here. You can see it stopped on line 24. If I try to type in PO card array right now, it's going to be 0 elements. Why? Because we declared card array as an empty array here, and it hasn't executed this line of code yet to grab the cards from the card model and assign it to the card array. So actually I need to set the breakpoint one line after the variable gets assigned that I want to check. So to recap, you can use breakpoints and set them in certain branches of code or certain methods that you want to be alerted to and have the execution stop when it hits to let you know that it is reaching that point in the code. Or you can use breakpoints to stop the execution of code at any line of code that you want, and then at that point you can use these commands in the console window to double check what's inside your variables and objects and properties at that point in time. That's one thing that I didn't stress actually, is that when your execution stops at that breakpoint, when you're checking all of the objects and the variables and what's in them, it is that state of that object or variable or property at that point of the execution. And that's why it's such a great tool in the debugging tool set, because it's almost like you can freeze time as your app is executing and you can double check things. Now, another way that you can check things is actually there's a little window over here on the left, and it kind of shows you all of the active things in memory. And you can see that I do have a card array here. It's 0 values at this point. Again, it's stopped here. Let me just click this button here to control the execution. And we're going to talk about these buttons in the next part of this video in a little while. But I've moved the execution to the next line, so it has executed this line of code and taken the cards from the card model and assigned it to card array. And now in this little window here, I can see that card array actually has these, and I can just expand this tree node, and it might actually be a little easier for you to read, right? So now that we've talked about breakpoints and you know how to stop execution at a specific line of code, we can talk about these controls down here, which let you step through or trace your code. And tracing your code is just a fancy term for walking through your code line by line. So why is this important? Because it basically allows you to go through your code line by line with a fine-tooth comb. You know how we just used the example where you can set a breakpoint on this line and then it stops the execution of code at that line, and you can kind of double check on all of the variables, properties, objects using these two panes down here. Well, tracing allows you to move this green line to the next row of code, and then you can do all of the same things. So you can move through your code line by line while checking how all of these objects, properties, variables, how the values change inside of them. So you can see exactly where things are changing and try to find out where your bug is if you're trying to figure out why some sort of weird behavior is going on. So let me demonstrate to you what some of these buttons do. The first one, and the easiest one to explain, is if you've paused the execution of your code using a breakpoint and you want to just continue the execution, and in other words resume, you can hit this button right here, continue program execution. Okay, so now let me set the breakpoint. Let's say in here did select item at, and we are going to tap on a card like that. And it always starts with a breakpoint because you need to pause the execution at some point. And once it's paused, then you can use these buttons to navigate. So this one is probably the one you'll use the most often after continue program execution, and that is step over. So when you hit this button, it's basically going to move the green line to your next row of code. Right, so now the execution is paused right here. If I want to execute this line of code and move to the next one and pause, I can click on step over again. So now I'm here. And if I wanted to, let's say I'm not sure if the program execution is going to go into this if statement, well, let's step over and find out. So it does, it goes into this if statement. Your next command is step into. See, whereas step over is just going to run through the lines of code in this block of code or this method that you're looking at, step into will actually dive into this method that I'm currently at. If I just tapped on step over, it would just come to this line of code having executed this line of code. However, if I hit step into right now, it is actually going to dive deeper and go into the flip method, where now I can navigate through the code in the flip method. And similarly, step out will exit the function and come back out here. So in terms of tracing code, those four are going to be the main ones you're going to be using to navigate around in your code. And tracing is usually used in conjunction with breakpoints because, like I said, you need to stop the execution first at some point and then walk through your code using these buttons down here. So the way to use this debugging technique is if you're detecting a problem in your app, you might have some sort of inkling about what might be going wrong, maybe what area. So you start there, you set a breakpoint in the area where you think something is going wrong with a breakpoint. You run your app so that it pauses it at that point in time, and then you you check all of your objects and properties and variables at that point, and then you slowly, using these tracing buttons here, step through your code line by line and try to pinpoint the exact line of code which is causing unexpected behavior, or the line of code which is generating values that you don't expect to get. So now we come to the last debugging tool that we're going to talk about in this lesson, and that is conditional breakpoints. What are they? Well, in your breakpoint that you set here, let me just stop the app right now, you can actually double click it, and that's going to pop up this dialog which will allow you to add a condition. And basically that says that the breakpoint will only trigger if that condition is true. Why is this useful? Well, let's take a look. If we go to, let's say, the card model, where there's a loop, and this loop just runs 8 times, but let's say I had a loop that ran 1,000 times, and there was maybe only a very specific case that was causing an issue. So I would set a breakpoint here, and let me just run the app right now so that the breakpoint gets hit. So let's say this loop runs 1,000 times, and there was a very specific scenario which I wanted to pause the execution at, and I wanted to take a look at the variables and see what's going on, why my issue is happening. Well, I would probably have to keep hitting this continue program execution, looking for that specific scenario while it basically loops 1,000 times. Instead, I can set a condition on my breakpoint to, let's say, that only pause the execution when the random number is greater than, I don't know, 7. So let's say that. You can see your breakpoint changes a little bit. It has this little white triangle instead. And I actually want to move this right there, because this is, at this point, this is when random number gets set. So this breakpoint right here is only going to trigger when generated random number is greater than 7. So I can now just continue program execution, and it's paused it down here. So why did it pause it? Because the random number, as you can see down here, is 11. All right, let's continue program execution, and you can see that it didn't pause it for the last number because it was 5. All right, so let me just run it again. So the first number is 9, so it paused it. Second number is 1, so it didn't pause it. Right now it's paused it on this line because random number is 11. So that is conditional breakpoints. So the cool thing about conditional breakpoints, aside from the scenario I just showed you, is that you can also use it preemptively in your code. So let's say that I was building this method here and I was writing out the code, and I'm expecting to generating numbers from 1 to 13. Now that's my assumption, right? And if I wanted to get alerted if that assumption is incorrect, all I would have to do is set a breakpoint, let's say like this, and only stop if random number is, let's say, greater than 14, right? I want it to be alerted if this happens. Now this is preemptive because I'm expecting my code not to ever have to stop, right? But if it does happen that for some reason I get a random number that's greater than 14, then the execution would pause, it would hit this breakpoint, it would trigger, and then I could check out why that is happening. The last thing we're going to talk about is how to debug your visual hierarchy. So let me just remove this breakpoint, and to demonstrate, I'm going to have to run the project. There's another breakpoint. Let me get rid of that. Continue program execution. Let's say that you use the debugging tools you just learned about and you figured out that the card model is returning 16 objects. So now the question becomes, why isn't the view controller displaying these objects into the collection view? Well, my second thing that I would think about is in the collection view for this method here, number of items in section, which controls us telling the collection view how many items there are to display. Are you returning the right amount of items? Because if you're returning 0 here, then the collection view is going to think that there are 0 items to display. Now this checks out. The next thing I would think about, if the collection view thinks there actually are 16 items to display, why don't we see anything? then I would take a look at the cell for item at, because here you're passing a cell to the collection view to display. And if this all checks out, then you start to wonder, okay, something is wrong here. Maybe my collection view doesn't have a width or doesn't have a height, or it's just invisible or something like that. You start wondering about your actual user interface. So there's actually a way to take a look at how things are laid out in your UI when your app is running and these objects are generated here. So right here on the left hand side, you're going to see a whole bunch of information on your app, but there's this little button here that you can view the UI hierarchy. And if you click that, you're going to see that you get to see your UI here and how all of these different elements that are displayed here are in this what's called the visual hierarchy. So you have your UI window, you have your view for your view controller, and then you can start taking a look at all of these things. You have the UI image view, it highlights it here, which is the background, and then you have your collection view here, and then inside you have individual cells, right? And then you can dive into a cell and you can see that the cell is a UI view. It's got an image view. Well, this one's down here. You see it highlighted. The cool thing though is you can actually drag it and rotate it, and there's a bar here where you can kind of expand out the layers, so you can kind of see, you know, how your things are arranged. You know, this is, see that UI view there, this is the image view, this collection view, there's the background image. And if you don't see your collection view, then you know it's positioned incorrectly. Or maybe if you try to highlight your collection view and it's like this little sliver of a rectangle, then you know that it's not sized properly. And then furthermore, you can tap on a cell such as, let's say something like this, and you can see if your cell is sized properly as well. And if it is sized properly, you can see, maybe click on this guy, maybe the image view is not positioned correctly within the cell. So all of these things you can see visually, and it's easier to debug if it turns out to be a user interface related bug after you've checked out the code first. Or you might decide to approach it from the opposite side. So instead of checking your code first, you would check the UI first, and you would see that everything in your UI checks out, and then you would go and set breakpoints and start tracing your code to figure out why there aren't 16 cards being returned to the view controller. So below the video, you're going to find a debugging cheat sheet, which you can keep handy. The next time you run into an issue, you can run through some steps on this cheat sheet, and it's also going to remind you about the tools at your disposal that we talked about in this lesson. In addition to that though, there are a couple of sample projects which you can get some practice using these tools. They actually have some problems with them. I'm going to write down exactly what you need to figure out, and you can try using the debugging tools that you learned about in this video to try and solve the problem and figure out that line of code which is causing the issue. So try your hand at that. It's going to get you a little more familiar and comfortable with these debugging tools in Xcode.
Alright, so that was a pretty important lesson where you learned about various tracing and debugging techniques to figure out what's going on with your app. I've also got a debugging cheat sheet for you so that you can refer back to it the next time your app crashes to jog your memory about the various tools and techniques at your disposal. But before we go there, let's do a quick recap. In this video, you learned about logging, where you can output information to the console area so that you can visually inspect it. You also learned about breakpoints that let you pause the execution at a specific line of code. You learned about tracing that lets you step through your code line by line so that you can identify the point in time where your code deviates from what you're expecting it to do. You learned about conditional breakpoints that lets you pause the execution only if a certain condition is met. And finally, you learned about inspecting the visual hierarchy so that you can see all of your elements in your view are sized and positioned how you expect it to be. Now, the next time your project is crashing, refer back to this video or the cheat sheet and try to figure out your problem on your own. I guarantee you that you're going to learn a whole ton more compared to if I just told you what the problem with your code was. And also, the feeling of satisfaction that you get from solving your own issue is one of the best feelings and the best things about programming. It's like solving a really tough puzzle or finally cracking the code. And when you finally solve your own problem, it creates this memory in your head so that the next time you see this, you know exactly what to do, and you're probably not going to commit the same mistake again. Now, the more of these types of experiences that you can build up, the more of a veteran coder you'll be. All right, you're doing amazing so far. I'll see you in the next lesson.